Thank you, Chuck. I will let you take it away now.
Thanks, Ingrid. Well, welcome everybody. We're here today to talk about PaveXpress, a simplified pavement design tool. So, um, kind of a brief overview, why PaveXpress. I'll go through what is it. I'll give you an introduction. We'll go through an overview of how it works and look at how we can design an asphalt pavement in PaveXpress or an asphalt pavement overlay. And then, as Ingrid said, after we get through all the presentation slides, we'll open up the website and look at the application and see how it works. And we can go through some examples there and have some kind of interaction there if you guys have specific things that we want to look at how it works. So starting in 1996, AASHTO, the American Association of State Highway and Transportation Officials, began developing a new pavement design methodology for the use by state highway agencies, known as the Mechanistic Empirical Pavement Design Guide, MEPDG. And this methodology was adopted by AASHTO in 2007. While it improved the approach for designing high truck volume pavements for state DOTs, the practicality and applicability to local agencies and consultants for low volume road designs are questionable. Many agencies have long been comfortable with the 1993 AASHTO guide for design of pavement structures and the associated software known as Darwin. However, Darwin software is no longer available, and local agencies and consultants are faced with the lack of well-supported pavement design tools in the marketplace. So what is PaveXpress? It's a free online tool to help you create a simplified pavement designs using key engineering inputs based on the AASHTO 1993 and 1998 supplemental pavement design process. So it's a simple system to still do that pavement design according to AASHTO, since Darwin is no longer around. Accessible via the web and mobile devices. I mean, you can get on your computer, you can use it on a tablet or an iPad, you can even get onto it on your phone. It's free, there's no cost to use it. All you need is an email to sign up for an account and create a password, and it'll save all of your designs for you. And like I said, it's based on the AASHTO pavement design equations. It's very user-friendly. It has been updated throughout the years. They've added new modules, which we'll go through some of those, and just kind of, make refinements on the user interface to make it easier and more easy to understand. There are also interactive help and resource links within PaveXpress. There's a Pave Instruct, which gives you a lot of background on pavement design and things like that. And I can show you some of that stuff when we get into the web application itself. So when we talk about the 1993 AASHTO Design Guide, the equation was derived from empirical information obtained at the AASHTO road tests, which was done in the 1960s. And the solution represents the average amount of traffic that can be sustained by a roadway before deteriorating to some terminal level of serviceability, according to the supplied inputs. So if we remember our pavement design classes, we remember the AASHTO Design Guide equation. In this equation, the thickness of the new asphalt pavement is very dependent on basically three inputs. The first one is the subgrade strength, known as the resilient modulus. Slight changes in this value can greatly impact the design thickness, and it's imperative that the design have a good handle on this value. The second value is serviceability. Simply put, serviceability is related to ride quality, so how smooth the pavement is initially and how rough you allow it to get before it's replaced. So smaller change in the value, the thicker your pavement's going to be, basically. And then finally, traffic and how many load repetitions or easels, equivalent single axle loadings, that the pavement will experience over the design life. So more easels, thicker the pavement goes. So once the required structural number is calculated, then the total pavement thickness is determined. Typically, the pavement designer will have a policy defined layer coefficients for each material, and how thick each material will be, and a policy defined drainage coefficient for unbrowned materials. Um, for example, the common layer coefficient for asphalt materials is 0.44. Each layer of asphalt is a set thickness. Um, so you can design your pavement and then calculate how much thickness you need there. And there's different ways of doing it. You can do it multiple layers of asphalt or just a single thickness of asphalt. The sub base is usually a set thickness, such as 6 or 8 inches of aggregate base. You can add in sand sub base layers. There's a lot of different options in there. But once we have all these known inputs, the designer solves for the overall structural number that is needed to accommodate all the structural number to protect the layers below. So we'll go through all this. So we will cover when you open up PaveXpress, this is kind of the landing page. And what we're going to cover today, like I discussed, was the new construction design process and then an overlay of an asphalt design. So we'll begin with a new asphalt pavement design, and I'm going to basically kind of step through the different screens here in this session to give you a feel of the inputs and what all is needed to complete a design. So once you sign into PaveXpress, we start with inputting some basic project information, project name, state, owner, description, and basically that's going to kind of be your project name. Next, we'll be talking about pavement design. So we select design, and you can see here the other tabs: LCCA, agency cost, per road, and structure. These are newer applications that have been added to this, like the LCCA. You can take designs and compare your life cycle cost and do a life cycle cost analysis. Agency costs, you can look at cost of materials for a specific design. Per road, there you can get inputs for determining if you have a perpetual pavement. And then structure, you can get more detailed structural analysis for like MEPDG inputs and things like that. So there's a lot of different things here. We're going to be focusing on designing of pavements. So we would be in the design tab and click on new to create a new design. So our next screen that comes up is our design scenario. PaveXpress allows new pavement designs for asphalt pavements, concrete pavements, porous pavements, new asphalt overlays on existing asphalt pavements, but the asphalt overlay design on concrete or composite pavement is not yet been implemented. The next screen, after we've got our kind of our basic information there, we get into our design parameters. Or no, this is still the scenario information. I'm sorry, I'm jumping ahead a little bit. So this is what it looks like. We put in our new scenario name and a description. You want to put in your estimated completion date, roadway classification, and your project state. Those are the inputs for here, and I've got a little more information on those. So basically the project name, that's an open field. You can put in whatever you want. The description, also an open field. You want to just put in a description for what this design is. Estimated completion year, this is where you want to, when is the construction going to be done? That way we can extrapolate any growth in traffic that may occur while the project is being constructed. Say you have, traffic data from a couple of years ago, you can extrapolate that out into your completion year. And then state uses a drop down that allows the user to select the state. That can be important. There is with there are some state specific information within the application, so that if you want more information on what the state does, you can get that there as well. Roadway classification, this is a very important um, box on our first screen. It really helps set the default values for a lot of the different fields in the application. Um, so selecting, what type of a road it is it, limited access or controlled access like interstate freeways, and or is it a local road or a collector, or what kind of classification that is. That goes into setting the default values in your AASHTO design. Um, so this gives us a little more information on the different types of road, interstates. Those are all the, interstate freeways, arterials and highways. Those ones have, separate directional lanes, usually separated by some kind of physical barrier. Local roads not intended for use in long distance travel, you know, and then residential collectors, those are kind of your lowest traffic level loadings, basically comprised of automobiles, periodic truck traffic. So. Next, the user must input various design information. If you recall the flexible pavement design equation, this screen allows for the user to change the defaults. The defaults are based on the roadway classification that's selected by the designer. So your basic, design period, um, initial terminal serviceability, reliability, and combined standard error there are default levels, based on your roadway classification. If you're, designing an interstate freeway, your reliability level is going to be higher, and your initial and terminal serviceability are probably going to be a wider spread there than for like a local road. But you
Sorry.
can go in and change those. Yes.
So just to be clear, when you pull up a brand new project and you select some of these things, these will be those numbers will default in there. You won't have blank
Yes.
spaces. Okay.
Yep.
And then you can
Yeah.
adjust as you would like.
You can adjust as you like, and you can see on the screen here, and I'll be able to show it better when we're in the actual program, the little green question marks. If you hover over those, they kind of give you general kind of inputs of, for this roadway classification, it should be between this and this.
So if you really had very limited information about a project and you were maybe in the very beginning stages of thinking about a pavement project, you could still get something out of this.
Yes. Yes.
Perfect.
Yep. Yeah. It's nice in that way that it kind of preloads some of those defaults. And some of them you got to look at, based on your state specifics or your material specific things that you need to change. So,
But at
yep.
least gives you a starting
At least
spot.
gives you a starting point. Yes.
I've got another question in the chat. Can you change the PSI input to a Pazer input or no?
Not really. It's based on, because it is based on the 1993 AASHTO design, and they use the PSI. We did talk a little bit about that in the pavement design class last week. It's similar. PSI goes from 0 to 5, where Pacer goes 0 to 10. But really, the serviceability was set up during the road test and that, and it is similar because it was basically people's feelings about how the roadway looked and rode and that. So, and where they thought, the terminal serviceability was. And, depending on your roadway classification, your terminal serviceability may be a little higher. Maybe it's 3, and on some other like lower volume roads and things like that, maybe it's a 2.
Okay.
So, yeah.
And then I've got one more question while I've got you stopped. I got a question in the Q&A as to if the software can be used to design parking lots or non-roadway type pavements.
Yes, there is an option for parking lots. A lot of that gets linked out to like SAPA parking lot pavement design guides or the National Asphalt Pavement Association parking lot guides and things like that. There's not an AASHTO equation for that, but there is some guidance on that.
Awesome. All right, I think we're caught up now. I'll let you get back to it.
Great. Um, Basically going through the design parameters, design period is the length of time the design is intended to last before the pavement reaches the end of its serviceability life and requires rehabilitation. Um, so defining that design period really affects, has a lot of effect on your traffic, because then you're going to extrapolate that traffic over that design period to come up with what are your, traffic loadings or your easels. Reliability level, that's the probability the pavement section design using the process will perform satisfactory over the traffic environmental conditions for the design. Um, and this is used when determining the corresponding Z sub R. Uh, when we talk about reliability, um, you know, obviously Z sub R increases as R increases, changing from negative to positive when R is 40. So this is all your statistics. But there are guidelines within the application on what you should choose for your reliability factor. And here it is, the AASHTO suggested reliability levels for various functional classifications. So you can see for the interstate, other freeways, you've got that higher reliability level, and lower as you get down to the locals roads. Combined standard error, that's a variable that defines the overall design uncertainty involved with traffic and performance design inputs. The likelihood that the observed values during the pavement serviceability life will deviate from these inputs. It's not really recommended to change this from 0.5 for flexible pavements. AASHTO, that's just the typical value that's used. So that's usually what people use. The initial terminal and the change in serviceability, we talked about this a little bit, but the initial is right after construction. The terminal is when it's exhausted and you're at the end of your serviceable life. And then you need that change in serviceability for calculating your structural number. This is just kind of a, looking at, serviceability. And as I said, the PaveXpress default range for terminal serviceability is typically between 2 and 3. And, initial default serviceability is usually 4.5. Basically, nothing's ever constructed to be perfect, but it's close. It'd be like a PACER rating of 9, I guess, instead of 10. So this table here kind of shows you the effect on roadway classification has on the default values. So if you select the interstate, your default design period is going to be 20. You're looking at a residential or collector, it's 20. Interstate was 40. So, and then you can see how the reliability level changes. That combined standard error, like I said, that's always 0.5. Then your initial serviceability is 4.5, and then you can see the terminal serviceability goes from 3 down to 2 based on that. So your change in serviceability, you got 1.5 for the interstate, so that's going to give you a thicker pavement section, and the 2.5 typically gives you a thinner pavement section. From the design parameters, we move on to the traffic data. PaveXpress gives the user a lot of flexibility to calculate or directly input the total number of easels over the design period. So when we think about easels, what is an equivalent single axle load? It's really the relative indication of how much damage different axle types carrying different loads do to a pavement. So we think about a typical 80 kilonewton or 18,000 pound dual wheel single axle. That gives us that one equivalent easel. As you get heavier, you've got greater easels, or lighter, a lot smaller easels. You can basically think, one truck, a typical 18 wheeler, does 10,000 times more damage than a car. Car equivalent easel is, 2 thousandths, whereas that 18-wheeler, your equivalent single axle loading is like 2.4. So from the design, we're looking at the traffic data. Like I said, it gives you a lot of flexibility. You can calculate from average annual daily traffic. You can calculate from annual easels if you have that data, or you can, if you've calculated your design easels, you can directly input those as well. So we'll talk a little bit about how we calculate from the average annual daily traffic. So we can estimate the annual, if we have some basic traffic information, we can use this average annual daily traffic approach. Basic information is what we need. So if we have that average annual daily traffic, we can look at, how many lanes were measured, what direction, and all that. You've got the year of the traffic count, and you can also add in a growth rate. So based on historical growth rate, what that is. And then it'll calculate that completion year of traffic. So that's where it's important that, if you have older traffic counts, and then we're going to put that into when the project is going to be completed to figure out what our completion year traffic is.
Chuck, I've got another question in the chat here about electric vehicles, if the weight of electric vehicles changes the easel value at all.
It may, change that a little bit for cars. That's something that'll have to definitely be researched. I mean, even, your typical values that you use for cars now, it's kind of a mix of
Yeah.
traffic as well. I mean, there are heavier cars on the road than there are. But the main point is understanding what your traffic is. When we get into doing a MEPDG design, you're looking at every piece of traffic and the different load configurations and load spectra, and it gets into a whole, this simplified process is how many, what's our traffic count, and then we estimate how many percent of that is trucks and how many percent of that is cars, and then we come up with a load equivalency factors and calculate our easels. So
Yeah,
I would
so
imagine,
unless you like maybe right in front of a dealership that for electric cars or something where you're going to have a lot of traffic,
yeah,
it kind of shakes out in the mix of
yeah.
everything else.
Yeah, we try to kind of generalize everything. We're not breaking out, when we talk passenger vehicles, we're not breaking out, heavy vans versus, the smart car.
Right, right. I got another question in the chat. With the AADT calculator, how does AADT of 2,500 from 2003 result in over 900,000 at the end of the design life of the project?
Oh, he's looking at this calculation here and stuff.
Yes.
Yeah. Well, that's average annual daily traffic. So then it calculates out based on 365 days and all that. And so it calculates that out. And then
And there
based on the growth rate and
growth factor,
that,
yeah.
yep, yeah. Yep. And that's just traffic. That's like your completion year traffic count.
Yes.
Yep.
Yes.
Yeah.
And
Yeah.
that's by lane, right? Yes.
Yep. Yeah. It was lanes measured one way. So directional lanes one. So it's basically counting all of it and then multiplying that out.
Perfect. All right. I'll let you go back.
So once we have that completion year traffic, now we've got to calculate our load equivalency factors. So this starts getting into the question that we had on, the weighted load equivalency factors for passenger vehicles. And so in here, you can specify the percentages of different types of vehicles you have, and then you have the load equivalency factors for each of those types of vehicles. So your passenger vehicles, you can see the load equivalency factor of 0.0001. Single units, Those are like delivery trucks and things like that, double units. Those are your semi-tractor trailers with only one trailer, trains. And then that has this other. So you can put in different values of here. Um, so say for instance, my example on this one is always, up in the UP, we've got these big logging trucks that are very heavy and things like that. You can put in a different weighted load equivalency factor for that. So maybe that one has a load equivalency factor of 3.5, and you can put in a percentage there. Um, and the application will let you know if you don't have 100% of all your traffic figured out in here. So if you're putting in different percentages down here at the bottom, the total will turn red if it doesn't equal 100. So it's important to make sure that you have that in there. So from that, then we calculate the annual easels and, um, using those load equivalency factors.
We got a couple of questions.
Uh-huh.
So going back a couple of slides for the traffic growth factor, if you had 3%, are you inputting that as 3 or 0.3 or 0.3? How do you input that?
It'd be a 3 for
Okay.
3%. Yep.
Okay.
And
Um,
this is the historical growth rate. And then there's also a future growth rate, like you can put in later when we're calculating out the easels.
Perfect. And then we've also got a question for the load equivalency factor. Do you have a good rule of thumb for a trash hauler? This person said that's typically their heaviest load on parking lots and other pavements.
Yeah. Yeah. And I think, I don't know. It looks like, I mean, they say garbage trucks here in the single units is the
Mm-hmm.
0.6. So they're still not as heavy as those, semi tractor axles can be. That it's all based on that 18,000 pounds per axle. Um, so
And then, yeah, similar question if there's a factor, a good rule of thumb for fire trucks as well.
yeah, and I think those would probably be in that same single units.
Single
If
unit.
you do know like the heavier weights and things like that, like, well, outside of an asphalt plant or something, if you're designing a road there and you've got
Right?
loaded, trains of, with 80,000 pounds, 160 or 80,000 or 80 tons, so 160,000 pounds. And then by the axles, you're probably over that too. So you can calculate out a different load equivalency factor. Uh, the big part is knowing what your traffic is. I mean, these are kind of the default values here, and they're kind of general. But if you know that, hey, we've got a bunch of these types of vehicles that are using this road, and we know they weigh this much, you can calculate out a new load equivalency factor, and that's where you can put it in that other section at the bottom there.
Yeah, it gives you the ability to do some of that customization
Yes.
while still maybe not having all of the possible information you could ever have.
Yeah. Yep.
And then one last question here. Is there like a good rule of thumb for a top end for a growth rate? Where like well, this would be ridiculous because cars aren't going to be able to get through. Do you
Well,
have any
some of that
anything?
some of that gets into how many lanes do you have and things like,
Right.
it's, you get to where you don't usually see growth rates over, 5%.
Yeah.
I mean, it's just, you can look at historical data. I think when MDOT does their designs, they usually have data, historical data, and then they project that it'll be kind of a similar growth rate. I've never seen one over 2% that they
Yeah.
use. I mean, so yeah, and then we get to this, the ESO growth rate on this screen here when we're calculating, um, from annual easels. And, that is basically saying, are my trucks going to get heavier into the future? So typically I see that as 0 unless you know that, over time I'm going to see an increase, not only an increase in the number of trucks, but the weight of the trucks.
Yes.
So that's that part of it.
All right, I think we have caught up on questions.
Great. So yeah, this screen here, we're looking at the annual easels. So if we have a completion year easel and we take our design period, and then if we do want to add in a growth rate, like I said, the growth factor is typically 0. However, if the truck traffic stream is expected to change over the design period and trucks will be getting heavier, you can put a growth rate in there. So this taking those completion year easels, if we know that, then we can calculate out our total design easels over the design period. Yeah, so this is just a little more detail on that. So basically, if we were to change the value from 0 to 4%, the designer expects the truck loadings to get heavier over time. So that will greatly affect our total number of design easels. And then if we do have, say you have a traffic department that can analyze your traffic and calculate out your easels for you, you can directly input those in as well. I would say most of the time, especially for local roads and things like that, we're calculating based on AADT. The common question is, where can I find traffic data? Um, you know, Many DOTs post their traffic count data online. You can contact the traffic division of your DOT. They typically have some traffic data even on non-DOT roads. If you got a traffic division of a city, you can contact them. If no official traffic count is available, you can conduct a short-term count. I know that was kind of popular back when we were in college. We'd get hired on to do traffic counts for people. Go sit at corners and interview local people and businesses. The bottom line is you want to try to document in some way, what you've selected as your traffic inputs. This is a picture of an example of traffic data available online. This is from Michigan DOT. They've got some traffic values here. You can see the yellow lines there. There's a lot of the local roads in the area. They're down in those lower values, but you at least have some kind of place to start thinking about what that traffic is.
And for those of you, I'm going to drop a link to a YouTube video from a lunch and learn we did last September that was specifically about the basics of traffic counts and a little bit more detail in like using this website and some other stuff. So if you need that, that might be helpful for you.
Perfect. Okay, so at this point, we move on to screen 4. We start building the pavement structure. So far we've put in our design parameters, we've put in our traffic and loading, so we've got our design easels. And so now we start quantifying our pavement structure. And when we're talking about the asphalt part of the pavement structure, we can use a single lift or we can use multiple lifts. So at this point here, we're talking about multiple lifts. So if we were going to do that, we would fix our surface lift at a certain thickness, typically 1.5 inches. Here in Michigan, we use 5E mixes for our top course, typically placed at 1.5 inches. Our binder intermediate course, placed at 2 inches. So if we fix those thicknesses, and then we're going to figure out, okay, we have an overall thickness of asphalt, so the rest of it's going to be made up in our base course asphalt. And you can see here, we've got, you can treat the different pavement layers. You can input a different layer coefficient for each of those layers, or drainage coefficient for each of those layers as well. So when multiple lift option is selected, the user can input a set layer coefficient and thickness for each of the layers. And then PaveXpress will iterate to calculate the required base thickness. If we're doing a single asphalt lift, so here with this one, you're basically, okay, I want my design and figure out what's my total asphalt thickness. And then you have to input a minimum thickness into there, but then it'll calculate out your design to anything that's bigger than that. Otherwise, it'll just tell you what your minimum thickness is. But then you also have to include your layer coefficient in that. Then we can break out during design, when we're putting the plans together, and that as far as what our different lifts are going to be to come up with that total thickness.
I've got a couple of questions. One of which is, does this software offer recommendations for replacements, or is it strictly for new pavement, like full road construction?
For replacements,
Like for a
um,
mill and fill,
oh
can you?
yeah, yeah,
Yeah.
that's going to be the second part of the presentation here. You can do an overlay design here, and we're going to go through. I've got a bunch of slides on how we go through that as well. But right now we're focusing on I'm designing a brand new pavement. What are my thicknesses? Yep.
And then I got another question about, if we go back to the screen for the multiple asphalt lifts. I got a question about why can't you enter a base layer for that multi-lift? Why can't you enter in the thickness for that layer?
Because that's what we're going to calculate. When you use multiple layers, we're inputting what our, top course and our intermediate course are, and then we got to calculate a thickness. So the base is what the thickness that we're going to calculate. Similar to like, we go to the single lift and we don't put in a thickness. We put in a minimum thickness if we have a minimum thickness requirement. Because we don't want a design to come up, less than 3 inches or something.
Right, exactly.
But we're basically figuring out that thickness that we need to satisfy that structural number. So,
Perfect.
good. Oh, I kind of went, okay. So when we talk about these layer coefficients, layer coefficient is basically the measure of relative ability of that material to function as a structural component of the pavement. So that's part of the way that it converts into that structural number. So that a layer coefficient gets multiplied by the thickness, and that gives you the relative structural number for that layer. Drainage coefficient, this represents the relative loss of strength in that layer due to its drainage characteristics and the total time it's exposed to near saturation moisture conditions. So the designer may increase the value from the default of 1 where drainage conditions are favorable, or decrease it when drainage conditions are poor. And there are some guidelines on how to adjust that drainage, and we'll talk about that more in detail. And then minimum thickness, we've covered that. So layer coefficient considerations, keep in mind that, these layer coefficient does not consider a lot of different things, the improvements that have been made to asphalt and things like that. Typical AASHTO recommendation for asphalt is 0.44. Here in Michigan, the Michigan Department of Transportation uses 0.42. So they're being a little more conservative in that way. Years ago, they used to have the asphalt base course be 0.36. So now they recognize that all of our asphalt mixes are the same, so they should all be 0.44. But there are some states that have, increased the asphalt layer coefficient up to 0.54 based on some research that was done on their materials and things like that. So, but I would say typically AASHTO recommendation of 0.44 is good. If you want to be a little more conservative, you can be like MDOT and use 0.42. And then the layer coefficients for like a crushed stone base, like a typical ag base, 0.14, a sandy gravel sub base, 0.11. These are typical values. Those are the same values that MDOT uses for a dense graded base and their sand sub base. And drainage coefficient considerations. Keep in mind that many agencies just use a value of 1 unless you have better information. Stick with that value greater than 1. Like I said, within the pavement structure, will thin it, and less than 1, it'll make it a little thicker. So So these are recommended values for modifying structural layer coefficients of untreated base and sub-base materials for flexible pavements. You can see you get very poor quality soils. You can get all the way down to 0.4 if it's saturated more than 25% of the time and it doesn't drain very good. So changing those drainage layer coefficients can have a big effect. So once we've got our pavement structure in there, we look at the next screen here, the next tab, and that's our substructure. So will this pavement have a sub base and how strong is the subgrade? That's where we input the values into here. So you can add in layers such as an aggregate base or sub base, a lime treated base, cement treated base. There's a lot of different options in here. And the thickness and resilient modulus of each layer must also be input. So adding an aggregate base layer, we can add that in here. It'll be a lot easier when I show you how to do this, but basically for the 1993 design approach, the key inputs are the layer coefficient, drainage coefficient, and thickness. That's on the other slide. Okay, so here we're talking about adding in a base layer. Yeah, so we've got to add in those layer drainage thickness coefficients and a resilient modulus. AASHTO recommended minimum thicknesses here for the base layers, 4 inches for less than 500,000 easels and 6 inches for greater than 500,000 easels. I'll be able to show you this stuff a little bit better when we go into an actual application. So after the sub base is input, the strength of the subgrade is required. This is probably one of the most important parts of the design is that resilient modulus of the subgrade. The user can input CBR, R value, or the resilient modulus, depending on what kind of information they have. For CBR and R value, a correlation to resilient modulus is used. So if you do know those values, the program will calculate out what your resilient modulus is. So what is the California bearing ratio test? It can be performed either in the lab or in the field. There are the test methods, the AASHTO T193, ASTM D1883, or the field one is ASTM D4429. CBR is a simple test that compares the bearing capacity of a material with a standard well-graded crushed stone, which has a reference CBR value of 100%. Fine-grained soils typically have values of less than 20 when we're talking about CBR. You can also use the dynamic cone penetrometer if you're testing in field and in-place material for your subgrade. That's ASTM D6951, and it's used to estimate a CBR value. The U.S. Army Corps of Engineers Waterways Experiment Station developed the following relationship, so we can convert that DPI to a CBR. Other relationships have been developed also. So if you do have some DCP testing done, you can figure out what that CBR value is and get to what your modulus value is. When we talk about resistance value, that's the R value. Resistance test is performed in the lab. AASHTO T190 and the ASTM D2844. It tests both treated and untreated laboratory compacted soils or aggregates with a stabilometer and expansion pressure devices. It tests the ability of the material to resist lateral spreading due to an applied vertical load. So the range of values are established from 0 to 100, where 0 is the resistance of water and 100 is the resistance of steel. So kind of gives you a relative resistance to spreading out value. Or you can test resilient modulus directly. The resilient modulus test is performed in the lab as well. And AASHTO T307 or ASTM D2844. It's a measure of the soil stiffness and triaxially tests both treated and untreated laboratory compacted samples under conditions that simulate the physical conditions and stress states of materials beneath flexible pavements subject to moving wheel loads. As a mechanistic test measuring fundamental material properties, it's often thought preferable to the empirical CBR and R value tests. So PaveXpress uses some common empirical expressions used to estimate the resilient modulus from the CBR and R values. These are the equations. Although these equations may help the designer evaluate materials, it's usually best to determine resilient modulus directly through testing, if possible, rather than using the correlation equations. But those are all the information you have. It gives you an idea of what to use for your resilient modulus.
And as the resident geotech, I'm going to bust in real quick here and just say that
Thank you.
the more important, your pavement is, if it is a unique pavement or a brand new pavement, or you are expecting really extreme loads, anything like that is going to make, like, you really need this pavement to be bulletproof, I would really encourage you guys to do that resilient modulus testing. Have that as part of your exploration plan when talk with your consultant or whoever is going to be doing that exploration for you, and getting those soil samples and making sure that you do get some soil samples. The those correlations between some of the different tests, like CBR, you can get a R value, they all kind of will get you an answer, but all of those equations are they're empirical. They're our best guess. So if you can
Estimates.
yes, they are estimates. They are intelligent guesses, but they are our best guess on those. So the more that you need that pavement to really be bulletproof, the more I would encourage you to actually do the resilient modulus testing, as opposed to trying to work out something that is closer. I would go with the actual test. That is my PSA for the moment.
Yeah, and subgrade considerations, the Asphalt Institute publication IS 91 gives the following test values for various subgrade qualities. And basically you can see as the R value goes down and the California bearing ratio goes down, that the corresponding resilient modulus is going down as well. So like Ingrid said, if you can test the resilient modulus directly, that's the best way to know for sure what that resilient modulus is. So once we've input all of our base and sub-base things, we go to our design guidance. So basically, once you've got everything input, you get, what is my design? So in this example here, the required design structural number is 3.85. So I think this example here had the layers, the different layers of the asphalt. So you got the 1.5-inch surface, the 2-inch binder, and then it calculated a 3.5-inch base course for the asphalt. And that was based on having a 6-inch aggregate base underneath there. Gave us a total structural number of 3.92. So then this can give you all kinds of details on your design. You can print it, you can share it, you can send it out to other people, and things like that. So it's pretty simple. Once you got all the information, after a few minutes of data entry, we have a new pavement design. So the recommendation is, perform multiple iterations of the design with different plausible input values to get a sense of the range of pavement structures needed to carry your anticipated loads in various scenarios, and then use engineering judgment to select the optimum pavement structure. So you can do multiple iterations of this. You can see from here on the screen, it's laid out with the tab layout here. You can go back. So I could go back and change some of my design parameters or my pavement structure or traffic. and very quickly have another, run at the pavement design. You can also select different and save different scenarios. So instead of just iterating back and forth and not saving that particular design, you can save that design and then create a new scenario and maybe change one or two things and then see how, and then you could save multiple pavement designs within the system there. So that's a good way to kind of iterate back and forth. So kind of understanding the effects of PaveXpress default values on the calculated thickness. We'll review some important factors. Obviously, the design period, that plays a big role because that's going to calculate your total loadings over time. So the more longer your design period is, the thicker your pavement's going to end up being. Reliability level, as that increases, the calculated pavement thickness also increases. Initial serviceability index, if an occasion arises that it's lower than the default value of 4.5, the calculated pavement thickness would increase because the change in serviceability would by definition decrease. The program only allows you to input down to 4. Terminal serviceability, if you're choosing a different terminal serviceability than the default value, then the calculated pavement thickness would increase as the change in serviceability also decreases. So those types of things, just understanding how all that works. Obviously, the change in serviceability, as that decreases, the pavement thickness increases. Total easels, the more easels you have, the thicker your pavement becomes. Layer coefficients, as those layer coefficients increases, the calculated pavement thickness actually decreases. So layer coefficients are important. Drainage coefficients as well. So as any drainage coefficient decreases, your calculated pavement thickness increases, because this factor has a negative influence on the calculated thickness and likely decrease in pavement longevity. The subgrade should be modified in some manner to improve drainability instead of increasing asphalt thickness in hopes of bridging the problem. So if you do have very poor draining subgrades and things there, that's where they're talking about that maybe you should modify that subgrade so that it can stand up to the weight of the pavement above it. So that was the end of the pavement design part. And so next I'm going to kind of go into the doing a pavement overlay design. I don't know if there were any other questions here, Ingrid, on the pavement design before we start stepping through that.
Let's see. I've got one asking, should you include sub-base material and strength in your layer design? And if so, how deep should you cut off that layer of sub-base material? Go ahead.
Yeah, I mean, you can add a sub base too. I mean, a lot of it depends on what your subgrade material is. On
Yes.
say, for example, if we're on a poor subgrade material and that you might want to put a sand sub base and an aggregate base underneath that. Or if you're stabilizing the subgrade in that, then maybe you don't need as thick of a sand sub base or aggregate base over that. So there's a lot of considerations to go into that. And some of that's where you can kind of play around and kind of try to optimize your design. Yeah.
Yeah, the comment was sometimes we have 4 inches of clean sand below our existing aggregate, which that's a very reasonable thickness for a sub base.
Yes.
If you're getting into if the program is giving you some crazy thick layers, then maybe now you start, like Chuck said, start thinking about
Optimizing.
optimizing,
Mhm.
changing some things. Maybe you go with a stabilized subgrade or stabilized base, something that's going to give you a little bit more structure
Yeah.
rather than having 3 feet of sand.
Yeah. Then maybe you're just putting in a lot of extra and raising grade of your road and all that kind of, there's a lot of other considerations to take into that too.
Yes.
Okay, I will get into the overlay part of this. This one will go through a little quicker just because we've already covered a lot of it, but I'll kind of show you how when you're doing an overlay design, it's a little bit different because we're actually accounting for the existing pavement that's in place. Um, so PaveXpress can also perform overlay designs for rehabilitation design based on Chapter 5 of the 1993 AASHTO Design Guide. In Chapter 5, you can design overlays for flexible, rigid, and composite pavements. PaveXpress only performs these overlays on existing flexible pavements. For existing composite or rigid pavements, PaveXpress will provide a link to the repave application developed as part of the Sharp 2R23. Likewise, for concrete overlay designs, the repave application is available. However, the concrete overlay is not a design option in PaveXpress. For evaluating an existing pavement, Chapter 5 gives 3 options. We have only included the condition survey approach and the non-destructive testing method. We have built in some elementary pavement engineering into the program. We ask questions about milling, pouring, direction of crack propagation. Finally, the user will be required to enter layer coefficients for existing pavement layers, and the application will give recommended values based on the condition survey information. So screen 1, scenario information, we covered this earlier. However, notice the changes to the screen titles on the left and the new field at the bottom of the screen. Once the, I guess that doesn't really apply to here, I'm sorry. I had to update because part of PaveXpress is it's an application, so they update their screen sometimes to make it a little easier. So this presentation was a little old. So, but basically we're getting into scenario information. It's similar to what we did before. We call this scenario name asphalt overlay pavement design, scenario description, asphalt mill and fill. Same thing with completion year, roadway classification, and state. Next, we get into our layers, and here we want to input our existing pavement layers. So we put in the thickness of our asphalt. We put in if we have an aggregate base or a sub base and what those thicknesses are. We put in our subgrade. We've still got to know what that resilient modulus of our subgrade is, and then for our new asphalt overlay, we put in the layer coefficient and a minimum thickness there, as we will be calculating a total thickness for our overlay. So when we're adding existing layers for rehabilitation, we've got to know what our existing pavement section is. So we add those in here, and it gives you options for selecting different types of asphalt, aggregate base, cement treated base, asphalt stabilized base, sub base. You can add those in. Like I said, the subgrade soil type or modulus values for our subgrade, we can add that into here. Calculate, we can do our subgrade modulus the same way as when we're doing the new design. New asphalt overlay, to calculate the overlay thickness, we just need to know what our layer coefficient for the new asphalt is and the minimum thickness, like I said. And then it'll calculate our overlay. Design parameters, these are the same thing as we did with our new design. Now, typically when we're doing an overlay design, the default design period is 15 years. Typically with an overlay you're somewhere between 10 to 20 years. So you can adjust that is based on your experience on how long your overlays last and things like that. The reliability levels, the combined standard error, initial terminal change in serviceability, those are all kind of filled out based on your roadway classification again. So very similar to what we've already seen. Next, we get into the structural evaluation. And so this is where we're getting into, quantifying how damaged our pavement is. Because basically we would put in what our existing pavement is. That would have had a certain structural number when it was brand new, and now it's, X years old, and depending on what type of cracking and things like that are in there, we're going to basically lower that existing structural number and then calculate our overlay based on what's needed. So there are different ways that we can, do our structural evaluation, use a condition survey or non-destructive testing. Um, so, and, oh, yep, that's right here. So structural evaluation method, we can use the approach. Like I said before, there's 3 different approaches in the AASHTO guide: the condition survey, non-destructive testing, and the traffic method. The traffic method was not included into PaveXpress to determine the structural condition of the pavement. So um, I'm not sure what the whole traffic method was. I think it was just based on your traffic and some common, how much damage it might do over time, rather than looking at how much cracking is actually out there or going out and doing FWD testing. So with PaveXpress, those are our options, or the condition survey or the non-destructive testing. There are 2 condition survey methods. One is condition survey based on visual condition survey of the surface, and the other is a non-destructive testing method. Um, so with the condition survey based on visual, that's where you can input, types of cracking and levels of cracking into there. And the non-destructive testing is we're doing some uh, FWD testing and that kind of stuff to back calculate our moduluses. So we'll talk about the first one with the condition survey. There's basically 3 main areas that are required. So first, we have what type of alligator cracking and transverse cracking exist. For each severity level, what percentage of the pavement is affected. Inputting these values will adjust the recommended in-place layer coefficients. After the distress data, core information is requested. It's always a good idea to core the pavement, and if we have that information, we can input it into here. This allows the designer to record the material layer thicknesses, note any material distress, the direction of crack propagation, the depth of the cracks. All that stuff can be characterized into here. Finally, the user will be asked if the surface will be milled, and if so, how deep will the milling be? In some cases, this may remove all or part of the distressed asphalt. So based on the visual distress information, the cores, the milling, PaveXpress will provide an AASHTO recommendation for adjusted layer coefficients. And the user must use engineering judgment to select the best value. So on this screen here, you can see based on, the percent cracking, the core crack depth, direction, and all that stuff that we input, the AASHTO recommendation for the asphalt is 0.2 to 0.3. So you can see how that has degraded that, structural number for asphalt from 0.44 down to 0.2 or 0.3 based on how much distress is in the pavement. So we'd select a value typically in between there. And then same thing with the aggregate base and sub base based on the condition surveys. You lower those values.
So I've
Got a
got
question, Ingrid?
a couple of questions.
Uh-huh.
This is a good one. So when we're talking about the sub base layer, so this person, they've got a really thick, like 16 feet of really good sand sub base. And they're wondering what they should put in for a thickness because 16 feet is a little bit ridiculous.
You
in
you
terms,
just probably put that in as your subgrade
yes,
because you're
yes,
not removing it. A
right,
sub-base is more, I'm putting it in
yeah,
as a sub-base. If your subgrade is actually all sand, then that's gonna affect your resilient modulus of your subgrade. So
yeah, you're
instead of
gonna have a,
being, 5,000, 10,000, it might be 20,000 is your
yeah,
modulus, your
you
subgrade.
can bump that up. And the nice thing about the this program too is that you can do a couple of iterations and see if does putting it in a thickness here change anything? Does adjusting
Yeah.
that modulus change anything drastically?
Yeah. And
Um,
it'll also give you warnings too. Like say you did put in 16 feet of subbase. It'll probably give you a warning at the end that structural number exceeds required structural number because your layer protection checks, your subbase is basically stronger than the pavement you're putting on top of
right, right.
it.
All right. Another question is, do you always want to mill through the surface course before paving an overlay? Is that going to be a standard all the time?
You don't have to, no. It depends on the distress and type of distress you have. That's why it's important to take cores. Uh, Obviously, if you take cores on some of the cracks and stuff, and you see that the crack is propagating from the top down, and maybe it's confined in the first inch, if I just mill off an inch or inch and a half, I'm taking all that crack out of there. So then I'd probably want to do that. If if your pavement's cracked all the way through, maybe I don't want to just mill and resurface. Maybe I just want to overlay it because I'm going to get those cracks coming back up through anyway. Why don't I just add some extra structure and try to, bridge that? It might last a little longer because I've got a thicker structure still there. So there's a lot of different things you got to think about and that.
Um, then another question is, does this program allow you to do a combined pavement, like a composite HMA over concrete type pavement?
This one does not. It doesn't characterize the concrete pavements underneath. I I don't know if in the future it will. Um, I mean, I think that it said in there there's some reference materials on how to maybe do that. There's another program that can kind of estimate that for you. I think usually the problem with composite pavements or overlays on concrete pavements is, um, you get so much reflective cracking. It's really hard to characterize, you know, that layer below and trying to come up with a thickness design. Usually, it's kind of,
Yeah.
yeah. Oh, we're doing a short term fix. We'll just put a inch and a half overlay over it. We want it to last a little longer. Maybe we'll put a crack relief layer and a multiple course overlay on it. To kind of stop that reflective cracking or delay it. So a lot of that depends on what you're trying to do with your rehabilitation. Um,
And then we got another one. How would somebody determine the percentage to put in for that amount of cracks?
That depends on your condition survey. So you
Yeah.
gotta go out and look at it. You look at your pavement and its percent of area and things like that. And I can kind of show you some of that stuff when we go through there. But yeah, it's basically a condition assessment. So you've got to kind of know what type of cracking you have. Do you have that alligator cracking where it's, looks like an alligator's back in the wheel paths and things like that. Um, and then what percent of the area, and then severity,
Yeah.
is it just starting? Is it open up and raveling and I patched it all up? Because that'll what that does is it continues to lower these recommended structural number values or layer coefficient values that you want to input. So basically, if you have your based on your pavement thickness and structure when it was new, it had a structural value, say, of 5. Now, after 20 years, if I've got a lot of degradation to that, I might be down to a structural number of 2. So then, based on my 15-year life of this overlay, I've got so much traffic, I got to have this required structural number. Say it comes out to be a 5 again, then I need 3 part of, structural number to overlay that. I might have a lot thicker overlay.
Yeah.
So that's the basis of this kind of overlay process is how do I quantify what my existing pavement distress is done to that structural value of what's left?
Okay. And then last question here for a little bit is the minimum thickness of what is a minimum thickness for existing HMA that you want to remain when you're doing a mill and fill? Is there a rule of thumb? Is it like 2 inches? Um,
That again, that kind of depends on what's my total thickness. I
yeah,
mean, yeah, you'd probably want at least a couple inches left. Obviously, if I have a very thin pavement, I don't want to, mill out too much and only leave a half an inch there or something like that, because then you run the risk of, if it is in okay condition, maybe I damage it by driving on it with the
yeah.
equipment and the trucks and things like that. Um, so I know there are some, when we're talking about doing mill and fills, knowing what your existing cross section is important too, because if you have, you know, say an inch and a half or a 2 inch top course, you want to make sure that you mill it all off too sometimes so that you don't leave little, I don't know, skim areas of that top course on there, because then that can cause some issues during construction. So there are some things to think about with that as well.
Chuck, do you want
What
to
the
take like a
program
five?
does.
Do you want
Okay.
to take a 5 minute break before we get into the non-destructive testing, just to let
Yeah,
folks
we can
like
do that.
stretch? Does
Sure.
that
If
work?
everyone's,
We
yeah.
haven't. I
I've been
realize we have
talking for a
done.
long time, so
Yeah,
that's
I'm
fine.
like, I did a bad job of managing our time today. Normally I would have busted in and made you stop at an hour, but let's take a
Oh,
five
okay.
minute break. We'll come back at 10:20. Um, and if there are other questions, go ahead and put them in the chat. Thanks you guys for asking the questions. I'm sure that if you have the questions, somebody else does too. So we appreciate you guys asking. We'll come back at 10:20, and I will make sure that the slides are in the chat too if you joined late.
Great. Sounds good. Thanks, Ingrid.
Yes. All right, we're back. Um, I think go ahead. I've got a couple of questions in the chat, but we can save those ones for later. I'd say let's go on with our non-destructive testing.
Okay, sounds good. Let's see. So now if we use the non-destructive method over the condition survey method, instead of visual conditions, the structural capacity of the in-place pavement is evaluated. This is done by directly entering a subgrade modulus and structural number effective or allowing PaveXpress to calculate those values. If the subgrade modulus comes from a third-party application or software, make sure it's corrected. The correction factor is usually based on the type of subgrade soils. It should be noted this value from BAT calculation may not match the lab obtained value. The lab value may be from 1 or 2 soil samples. BAT calculation value usually comes from numerous test points and is either averaged or using a percentile value. If you choose to use the calculate subgrade modulus function in PaveXpress, please perform a sensitivity analysis. What is meant by this is select several radial distances and the corresponding sensor deflection. Note how much the calculated subgrade modulus changes. To be conservative, you may choose to use the radial distance that results in the lowest subgrade modulus. If you have test results from several locations, see how much they change the final modulus as well. Once a subgrade modulus is entered or calculated, then the effective structural number is entered or computed. To compute the value, use the deflection and load data from the test location used to calculate the subgrade modulus. Enter the total deflection under the load plate, the contact pressure load, and the load plate radius. These values will be used to compute the effective structural number. As touched on earlier, coring should be done on every project. It is always a good idea to core through cracks. Also note any delamination or stripping. This loss in bond will result in fatigue cracking above and eventually below that bond loss location. One other difference between the condition survey method and the non-destructive testing method is the assignment of a layer coefficient to the asphalt material that will be milled. If the pavement will be milled prior to applying the overlay, then the effective structural number must be adjusted. If the material to be milled is badly cracked, then it is contributing very little to the overall structural capacity of the pavement. Therefore, select a value following the AASHTO recommendations under the condition survey method as described earlier. Commonly, a badly cracked surface will have a layer coefficient between 0.1 and 0.15. Using this layer coefficient and the depth of milling, the calculated layer structural number is subtracted from the overall effective structural number. For example, if we calculate an effective structural number of 3 and we decide to mill 2 inches, the milled asphalt has a layer coefficient of 0.15, so the milled layer structural number is 0.3. That 2 inches times the 0.15. The resulting structural number after milling is 2.7. So once we're done with the structural evaluation, we have the traffic and loading. This is the same as we talked about in the new construction. The length of the design period may be different, but the other parameters are all stay the same. Once the parameters have been input, PaveXpress will calculate a required overlay thickness. This is the exact thickness to meet the required structural number for the overlay. It is not rounded. In this example, we're looking at, we removed 1.5 inches from the surface prior to performing the overlay, and we got a 4.1 inch overlay. So you know, once you've got this information, you want to make sure that, you know, you round up to what we can construct. So you wouldn't want to design a 4.1 inch overlay. That's the minimum. So you're going to probably do a 4.25 or a 4.5 inch overlay. So that's our design guidance. And once that existing pavement information is input, we use the AASHTO equations to calculate that existing or effective structural number, as we talked about. From the design and loading information, the required structural number to support the loadings is calculated, and that difference is converted to that overlay thickness. If this thickness is less than the minimum thickness input on earlier, or the required structural number is less than the existing structural number, then PaveXpress will report the minimum overlay thickness value.
So we've got a question is, how would you add a crushed HMA layer? Is that bituminous treated base, or is that something else?
If you're not really doing an overlay, if you're doing like a crush and shape and all that,
Yeah,
yeah, that you're probably going to want to do more in the like new pavement design, I would
right.
say, because you're kind of obliterating that old road. Some of it you're using, the subgrade's still the same. If you had sub base or any base left underneath that, then you'd want to quantify that accordingly. And say where you had, a 6-inch base, and 4 inches of asphalt, and we crush and shape the 4 inches with a couple inches of the ag base, we could kind of put that into our new design with 4 inches
Yeah.
of base, and then a asphalt treated kind of base and like that, and then build on top of that. I wouldn't
So
use the overlay part of this to do that.
yeah, you can still use this software, just not this part of the
Yeah,
software.
yeah, yeah.
Perfect.
I'd characterize that more as kind of a new construction, kind of reconstruction, I guess, a new design.
Great.
But that was the end of the presentation there. It's important to stress that, the design approaches in PaveXpress are based on the AASHTO 1993 method. The program has an extensive online help function and links to other websites for more information, which I can show you here. We'll get into that next. I'll bring up the actual website, and we can kind of poke around that, and I can show you some of the things that we've explained. Um, you can access the website by visiting PaveXpress.com. In addition, the Asphalt Pavement Alliance has conducted several webinars on PaveXpress that go into more detail around specific designs, and you can get to all that stuff right through the PaveXpress website too. There's a lot of help on there. There's videos of recorded webinars and things like that. So with that, there any other questions before I'll start sharing the
Not at the
website?
moment. No.
Okay.
Let's jump into it.
I'll, s- I'll see if I can shift over to that
Yes.
without losing anything. Uh, can you see the website now, Ingrid?
Yes, I can.
Okay. So you go to pavexpress.com, and this is the opening page here. And like I said before, all it takes is an email and a password, and you can get yourself all set up there. You scroll down this Pave Instruct. Um, that's a learning module. It's web-based pavement design education. I'll click on that here. That's kind of the more information and things like that. So you can see in here there's some videos and a lot of literature, different things like that. You can go back to PaveXpress. Pave Instruct is a learning center. Click on that, and there's different learning modules available that you can download and watch. Um, so go back to here, and to get started, um, I've already got a login in that, so I just go to launch. It'll take a second here to load up my projects. Um, and here we go. So this training project here, I can click on this and I can go in here and edit project. So that'll open that up and then I can make tweaks to it and stuff. So if I do that, or I can click on new project and that'll start a brand new project, and that kind of goes through, some of those screens that we had before. I'm going to open up this one here that I put together for this. So we've got a design. It's a new asphalt pavement design. The scenario type, asphalt pavement. If I wanted to create like a new scenario on this, I can click on here and hit new, or if I just want to edit it, I can edit it here. Has a copy function. I can copy this one to say I wanted to kind of use the same inputs and then copy it. You can do that as well.
So you could have one project file that had maybe
Multiple scenarios.
multiple scenarios for you. And then
Yeah.
it also looked like when you were on that first page too, with all of your different projects, that you can import a project. So like if I had a project and I was like, hey, Chuck, can you take a look at this?
Yes.
I could
Yeah.
send that to you and you
You
could
can send
import
it.
it.
Yeah. They're definitely shareable and that kind of stuff. You can send them to other people. Yep. Yeah, that's a good point there too. Yep. And you can see here on my list of projects, like some of them have different number of scenarios and stuff. So if I go into this one and if I create a new scenario, I can say I wanted to do, instead of the new asphalt, I want to do a new concrete. And then I could do a concrete design for that. And it'll keep a lot of those same inputs and stuff. And then you can get into, or if I want to do an overlay, or you probably wouldn't do that, but
But yeah, you could
can,
design your lanes and your shoulders and a parking lot all in one
yeah,
project.
all in one
Perfect.
project. Yeah. But if you want to go in and, you know, just look at what's input, and you can kind of toggle back and forth and see how it affects the design, you can do that. Um, as I said before, within each tab here, you can see the green question marks. Those are your quick helps. So if you just hover over that, it kind of gives you some information there, and kind of gives you an idea of what those are. Click on here, it's got the drop down menus, so you can collect different things here. So yeah, you can go parking lot in here, um, collectors, local, principal, interstate, all that stuff. Project state. We get into the design parameters. You can click save anytime you want, and then that'll save it right then. You can click next to go to the next one, or you can just click on the tabs too. It's kind of the same thing. So there's different ways of kind of moving around. There is a metric imperial button up here. If anyone does want to do their designs in metric, we've gone away from that here in the US. I don't know if there's any international people
It
on.
doesn't seem like we had anybody from Canada today, but sometimes we do. So you never
Yeah,
know.
yeah. So you can do that. If we wanted to go through and, do multiple iterations and save them, I would say, back in the My Projects tab here, um, instead of just going in and editing that particular project, um, apologize, I've got a lot of projects in here.
Mhm.
So it takes a minute to open up, but most people won't have that problem. Instead of going in and editing the project, well, I'll select it first. Instead of just editing it, I copy it. And so
Okay.
if I hit copy, oh no, that's share. That's not copy. Yeah. They've changed a few of these things on me. Okay, so that's sharing. It doesn't tell me that. I thought that was copy. They used to have a copy button there. So I guess I'd go into new scenario and it'd be new asphalt again. And so that didn't save my information. Okay, let me go back.
Sure. Sure. This is
Um,
the beauty of doing these things live. So folks, be
yeah,
patient.
sorry about that. It's yeah. So if I go into here, I see it just saved another one. because
Okay.
I put a new scenario in there. Um, so this is my old one probably. So I'll go back in here and edit this. So I wanted to be able to show you guys how we can change things in here. So this one here, these are kind of, I created this basically so that I could show the new pages and stuff within
Yeah.
PaveXpress. So a lot of these are in the presentation that everyone has a PDF of now. So if I wanted to change my roadway classification here, you can see here it's on local. If I go to my design parameters, you can see the 20-year design period, the initial terminal serviceability, reliability level. Let's go back here and I say, okay, let's, instead of being a local, I want to say it's an interstate. And go
Okay.
back next. Now all of a sudden on here, it's automatically changed my design period to 40. Like we talked about, it puts in those reliability level got pumped up to 95. So you can see how that
Okay.
affects it.
So you don't have to hit save for that to happen. As soon as you change one of those parameters, it will
It
change the
changes
rest
it.
of them.
Yep.
Does it
Yeah.
overwrite if you have put stuff in there? Um, like if you decided that you wanted your design period to, maybe you had it on local and you changed the design period to something else, does it overwrite when you change that, change to like interstate, or will it keep whatever you actually put in there?
Yeah. That's what I'm wondering because it used to have, I used to use the copy function to do that,
Yeah.
but I don't know. Maybe if I don't save it yet. Um, hmm, if I save this now, I go back. Did it create another one in there? Now I'm curious.
Yeah. It's not like you're
But
limited to how many you can have, obviously,
right,
or how many scenarios you could have in one project. But yeah,
yeah,
that would be good.
it did save it up here.
Okay.
Yeah. So yeah, so now it saved it here.
Okay.
So yeah, you can go back and forth and change that. I'll go back and change this back because we had it on local. And okay, so I don't think it saves it as a separate one until you hit save. So
Okay.
if I just toggle back through next and previous, or just clicking on the tabs, I can change things and then see how it affects my design.
Perfect.
So yeah, basically here we had 3.5, 2, and 1.5. So we've got 7 inches total asphalt over a 6-inch base. So
Okay.
if we make changes, we can see how it adjusts that. So if I go back to, say, for instance, I do move this back to the interstate, obviously that's gonna,
We would expect things to thicken up a little bit, hopefully.
yeah, because my design period all of a sudden doubled, right? So I go to design guidance, and now I'm at 5, 7, 8.5 inches.
Yeah.
So we added an inch and a half. So you can play around, you can change these. Um, Traffic and loading. I wanted to show you if we're calculating from AADT. Um, there's some help on here. If you hit learn more, it takes you to a website and can give you more information. But basically, if we completion year traffic, if we know that, we can put it in here. If you don't, you click on this tab here, this calculate from historic AADT. And that brings up this, I think I had a picture of this in the
Yeah.
presentation here too. So then we can put in our average annual daily traffic. Um, it gives you some information there. Lanes measured, was it a two-way count or a one-way count? Um, Directional lanes, how many lanes in each direction. If you select multiple lanes in a direction, then this multiplier is for your design lane. So um,
Okay.
the default is, if I've got 3 lanes in each direction, my multiplier, I assume 80% of the traffic is in that design lane.
Okay.
That's kind of like on a freeway, that's your slow lane, and then you have your passing lanes. There's typically less traffic in those, and you can adjust this up and down. So you can put in point 0.6.
Yeah, if you've got really great traffic data to use,
Yep.
might as well use it.
You can input that in there. You don't have to use the default values, but like we mentioned earlier, the default values are a good starting point for you. Um, yeah, year of traffic count, historical traffic growth rate, and we've got completion year traffic now. So, and then we go if, to calculate load equivalency factor. So here's where we talked about you want to enter these in. You can change the amount of traffic and see as I change that, the box down here in my total turns red. Traffic percent must add equal 100. So if I bump one of them up, I've got to lower one down. So you can play around with that. The
Okay.
other, if I have some other here, I've got to input a load equivalency factor for that.
Okay.
So say we had those really overloaded garbage trucks and my load equivalency factor is 4. So
Perfect.
I can input that there, and then that affects my overall weighted load equivalency factor, which then gets multiplied by my traffic and comes up with my easels. So that changed my completion year easels, and then we get into getting our total design easels. I got our design period, future traffic growth rate. If we wanted to add some traffic growth rate here, we can do that. Easel growth rate, if we want to do, say our trucks are going to get heavier over time, we can add that in here. And then our design easels have bumped up now.
Okay.
In the pavement structure, here's where we can selecting using multiple lifts. Again, this is where we've got, if we want to say our surface course is 1.5 inches, our base is 2, and then we want to calculate that asphalt base course thickness. That's what's going to happen. Or if we use a single lift, we can do that here. So I'll switch that over to single lift. That'll tell us what our total thickness is. If we go into substructure, this is where we can add in base layers. So say I wanted to add another layer. If I wanted
Okay.
to add like a sand sub base or something, I can click add layer, and I can select from here aggregate base, cement treated base, aggregate sub base. And you can see it populated the layer coefficient of 0.11. That's the default from AASHTO. Put in a thickness. And I can say, is that fixed or not? Typically, we're trying to figure out the asphalt thicknesses, so we fix those. If you don't fix those, sometimes it'll adjust those as part of optimizing your design as well. So
Okay.
if you don't have a standard, hey, we like to always put 6 inches of ag base over 4 inches of sand or whatever, you can do that too and optimize. Now, sometimes that could work, but for constructability purposes and things like that, people typically, have standards like 6 inches ag base over 10 inches of sand, and that's my base material. How thick is my asphalt above that? But
And that for anybody who's super new to this, that constructability is based on what could you spread out and compact? Like what's the thinnest layer that you could spread out and compact to what you need it to be compacted to? So
yeah,
it's a nice even and sturdy layer. And there
yes,
are some limitations. You cannot spread out 2 inches of
2 inches
gravel.
of sand
Yeah, it's gonna be hard.
or gravel or yeah,
Yeah.
yeah.
If you have one
And
inch gravel and you're trying to spread out a 2 inch layer of it, you're gonna have some problems. So
yeah. And most agencies have kind of a standard that they
yeah.
want all their roadways to have that kind of same starting point, and then we're putting pavement on top of it. Just that way it's easier for maintenance later, or if we're reconstructing, things like that. Uh,
Yeah.
you can do that. Subgrade modulus calculation. So if we have an R value, we can input that in here. And you can see how, as I adjust that, the resilient modulus changes below here. So you can change that. You can put in a CBR value as we put that. The resilient modulus changes as well. So that gives you kind of a starting point there. Or manual, then you can just enter that resilient modulus manually. Now, if you also know your soil type based on soil classification types and that, you can select that from here as well. So if we change that, and you can see down here, it gives you an estimated range of modulus values for that soil type when I change that soil type. So if nothing else, you don't have any test data, you don't have anything, you can use the soil types by looking at soil classification maps and things like that. It can give you an estimated range here, and then you can, use engineering judgment to input what modulus you want to have in there.
And the beauty of this is that you can run a couple of different scenarios to see how big of a difference is it going to make whether I pick, this soil type versus
Yeah,
that soil type, so that you have an idea and you can make a good, like you say, a good engineering judgment.
yeah.
I got a question in the chat about what if you wanted to add in something like a geogrid? Does the program support doing that, like adding in a geotextile?
No,
And
no,
what I
it
was
doesn't give it any structural value. Here we're doing a structural design, an astrostructural design. So, yeah, that wouldn't be in there.
the best I think you could maybe hope for is adjusting
Your
your
drainage.
modulus values to reflect that increase in strength.
Yes. Yeah, you can do that. Yeah, like say I put in a geogrid on my ag base or something, then maybe the resilient modulus isn't 28,000, maybe it's 35,000,
Yeah,
which you could change right here. Or you can bump up the layer coefficient and
right.
that'll change your value too. Let's see. Oh, that didn't go up. 0. Yeah, and then I could bump that up to like do something like that, and
Yeah.
then see how that affects your design, things like that. Um, yeah. So I was gonna say we put this at 10,000 modulus, and then our design thickness is 12 inches. Remember, this is a 40-year design for
Mm-hmm.
interstate with a lot of traffic. We made some tweaks in there, right?
Yes.
But if I go back here and I say my resilient modulus is 5,000, so it's a little, a worse
Mm-hmm.
soil condition. Now I'm at 15.5 inches.
Yeah.
So you can really see that modulus value is very important in the overall design thickness of things.
Yes.
I would say probably that one has the biggest swing as far as when we're doing a thickness design.
And those are the types of things, like we said, you can, investigate if you don't want 15 inches of asphalt. You can
Yeah.
investigate and changing some of those other layers, changing the parameters for some of those other layers, seeing if you can either thicken them or strengthen them or do something else so that they are not, uh,
Yeah.
you don't end up with that layer of asphalt.
Yeah. So yeah, there's a lot of different things that you can mess around with in here. I think, yeah, yeah, because yeah, we're pretty thick. We got 283 million easels.
That's a
That's
lot.
that's that's more than on any MDOT project.
Yeah. I think we've, yeah,
But we added growth rate, we added ESO growth rates, we added
yep.
we added some load equivalency factors that, really pump
Right.
all that stuff up. So, uh,
And so this is, a good example of you don't need as much information to do this design as you would if you're doing a mechanistic design, but you still do need good
good
information.
information. Yeah.
So, garbage in, garbage out when you're doing this, you want to make sure that you have the best, most accurate data that you possibly can. And it also is helpful that there are those default values in there to at least give you some idea of what reasonable numbers would be.
Yeah. Like if I go back to the local, kind of get it back to where we had it before. Mm-mm. Let's see. Yeah, let's see what that does. Yeah, that brought it down. So you can play around with that. Um, let's go through and look at the overlay design one.
Yeah.
So I can kind of show you how some of that stuff works as well. I see we've got about 8 minutes left, so
Yeah.
we'll do that one too. So this one is the overlay design. So got our scenario information. That's the same layers. These are where you put in your existing layers. So this is your existing pavement section. Um, so design parameters, same as before. Where it really gets into it is the structural evaluation. If we go to use the condition survey, this is where you want to input, do you have any cores? And that's a drop down menu, yes or no. So if we have cores, we're cores taken on the cracks. So we say no, then part of that goes away. But if we say yes, then crack type. So what types of cracking do we have? We have top down, entire depth. So if we have both, then that's one way of looking at it. If they're all top down only, then what's our depth of cracks? Um, so depth of cracks, we could say it's 1 inch. Any delamination or stripping, if we select yes, depth of distress. So, how far down is that stripping or delamination taking place? Because that's all going to factor into how much we're going to degrade that structural number value. Um, so those are the options in there. And then we've got, okay, what type of alligator cracking is, how much of low alligator cracking do we have? So in here, we want to, you got 3 severity levels, low, medium, and high. Percentages here are noted based on the surface area divided by the total area observed. So it's a percentage of that cracking there. So hovering over these kind of gives you that, what I was trying to explain to you, gives you that information here as well. So if we have any alligator cracking, we can, put that in here. Is it less than 10%, 0, or greater than 10%? Those are kind of your options for low severity cracking. Medium, same thing. We don't have any of that. So let's say we don't have any here. Transverse cracking, low severity, medium, and high. So a lot of that depends on like the width of those cracks. High severity cracks, your wider cracks there, and maybe you have some other associated distress outside of the main crack and things like that. Low severity cracking, that's, you've got a transverse crack across the pavement. It's probably just formed in the last year or two. There's not a lot of associated distress. It's pretty tight. May not even be sealed yet. Those types of things. Um, So then we get down into the distressed pavement, and are we going to move, mill, or repair? Sorry, fumbling over my lips now.
Mhm.
Mill or remove any of the distressed asphalt. So you can say yes or no. Say we're going to mill, depth to remove. So you can put in here, say we're going to do an 1.5 inch mill. So then it gives you your suggested layer coefficients here for your different levels. And it also lets you know that if you elected to mill 1.5 inches of the pavement, this might impact layer coefficient you select. And especially if, like here, if we're top down only, they're only 1 inch, but I'm milling 1.5 inches, well, I'm probably going to pick closer to this higher level of structural number value than the lower, because
Yeah,
in theory, I'm milling off all the cracking. So,
that's the hope at least.
yes. And if you don't, then you're going to get a thicker overlay design.
Yep.
Traffic and loading, same as before. And then our design guidance. So it says that our overlay is going to be 5.9 inches. You've removed 1.5 inches. And again, you can share that with people. Let them know how you came up with your overlay design and all that.
Yeah, if you want somebody to take a look and do a gut check, this is a great way to have all of the information in one spot to be able to send
Yes.
it to them.
Yeah. Yeah. And they'll be able to open it up and just look at it here with the right on the application. So
Yeah,
that's
excellent.
kind of a quick overview of that one as well. So if there's any last questions,
It doesn't look like we have any question. There is a question
okay.
about recommendations for over designing, you know, when you are doing that that initial design, or even for this overlay, is there um is there any rule of thumb about maybe over designing, especially for local agencies who may not be able to get back to that project for quite a long time?
Yeah. Well, and I think as far as like being too conservative and getting too thick or something like that, or you
Yeah,
can think of over designing as instead of designing for like 20 years, maybe I'll design a little longer, 30 years or something, even though, you know, the local thing says 20 years. You can input 30 years into there too and
yeah,
kind of design a little thicker for more traffic.
yep,
If you're constrained by budgets and things like that, then designing to 30 years worth of traffic and coming up with a 6 inch thick asphalt section when you don't have the money to build that, well,
right,
and maybe you need to scale that back and okay, I'm going to design for 15 years because
right,
probably
right.
by then I may not have the money yet, but there's a lot more engineering that goes into that than just a pavement design.
Right, right. And with this, you know, you could try the 30 years and see if there's some things that you can do to some of those. If you are doing a new construction, what can you do to those base or sub base layers to strengthen those?
Yeah,
Maybe you can get that asphalt layer
a little thinner.
reduced.
Yep.
So I do want to say thank you, Chuck. I did just drop the survey link into the chat. That's how you guys will get your certificate of attendance for today. I do want to say thank you to Chuck for doing this again. It will be recorded and we will send that link out to you as well as posting it on our YouTube page if that's something that you want to share with other folks. We encourage that as well. So we do appreciate, Chuck, that you are here. And if folks do have questions, you can ask Chuck as well. His contact info, I think, is in your slides. And
Yes.
so we do appreciate you guys attending today's session, and hopefully you learned a lot. If you have other questions, like I said, feel free to send them to me, to send them to Chuck, and grab that survey link before you go. So that you can fill out that evaluation form. Let us know what else you might want to see in the future, as well as that will be how you get your certificate of attendance. So we will hang out here for a few more minutes if folks do have questions, and also just to give you guys a chance to fill that survey out. If you attended with more than one person, there's a question in the survey that asks you, like, how many other people did you attend with? And if you need to put the number 0 in that one, otherwise it will not let you continue on with the survey. So thanks to Chuck, thanks to all of you, and hopefully we'll see you at a future event. We are planning to do some more asphalt sessions, lunch and learns in the spring. So we will hopefully have some more things to talk about then. And in terms of the design stuff too, if you've got specifics that you would like a class on, we will see what we can do. But thank you all again and hope to see you next time.
Thanks, Ingrid. Thanks, everybody.
And it doesn't look like we're getting any questions. This was a lot of information to get into 2 hours.
Yeah.
And I do
Well,
have a
hopefully it gave
request
them
for
a good
this.
overview, and, yeah.
Yes, hopefully it was a good overview and at least got folks thinking a little bit about this.
Yeah, and I think if they get in there and just play around with it, it's pretty easy to understand.
Yes. Yeah, and easy to make those changes and just to see what makes a difference
Yeah,
in your overall design.
yeah,
And I think having those default values is really helpful so you don't have to, like, what's a reasonable number to put in here? I know
yeah,
there's quite a few other programs where they don't give you any guidance on that. And especially considering some of them can make a big difference in your end
yeah,
goal.
yes,
It's nice to have a starting spot.
yeah, and sometimes it's a requirement that you have a pavement design done, so this can
Yep.
satisfy that requirement, and, you
Yes.
you have some kinda backup.
Yeah, you didn't make it up. This is actually what it's supposed to be. And also I approved that it's
And
supposed to be.
maybe you can justify it, "Well, we always do this."
Yes, exactly. Exactly. If you've got a typical for your agency, and you're wondering if maybe it is the right thing to do, this is a great way to check that.
Yeah.
All right, we'll probably give you guys until about 11:05, and then I'll close the room down. But like I said, if you have any problems with the survey, let me know in the chat. Otherwise, thanks, and you guys are free to go. Sometimes if I don't let people know that they're free to go, they will stay around for a while. Like, I promise it's over. So I'm going to stop recording now.